Hello geometry students, my name is Emigh, and this video is our discussion on section 1.7. Title is Coordinate Geometry, Midpoint and Distance Formulas. I want to start talking about the midpoint formula through an example. So we're asked to find the midpoint of the segment that joins point P, which is at -3, +3, and the point Q, which is at +1, 0. Now I want you to notice that I wrote xy and xy twice in this one problem. Well, in mathematics, we're not allowed to write the letter x twice if it represents two different things. So we have to differentiate between these two x's using a subscript. So I'm just going to put a little sub 1 and a little sub 2. And same thing for the y's. I'm going to differentiate them by putting a little sub 1 and a little sub 2. These sub 1s and sub 2s have nothing to do with computation. It's not like an exponent or anything. It's just a way for us to differentiate the two. All right, so to find the midpoint of the segment that joins these 2 points, we're going to start by finding the x-coordinate of capital M, which we're going to be call the midpoint. And we do so by adding up the x values and dividing by 2. All right, so we take our -3, add it with our 1, right here you can see that, and then we divide by 2. Careful with your negative work, and if you do that correctly, you get -1. Next, we're going to find our y-coordinate of our midpoint, and we do that by adding up the y-coordinates and dividing by 2. So we're going to add up our 3 and our 0, you can see that result right here, and divide by 2. Careful with your fraction work, you've got 3/2, which is an improper fraction. It's equivalent to 1.5 as a decimal. If they ask for it as a mixed number, it'd be 1.5. Always check your directions on what form they want the answer to be in. If they don't specify which form, then make sure you give them a form that is an exact answer, which all 3 of these are. All right, so that being said, the midpoint of our segment PQ is M, which has an x-coordinate of -1 and a y-coordinate of 1.5. All right, so now we're going to talk about, up here, we're going to talk about the general form of the midpoint formula, which can be a little overwhelming when you see it in this form. But just remember, don't let this overwhelm you. You just did it. The computation is not that bad. It's addition and division. So even though this looks a little frightening, you can get through this. So the the midpoint definition says, given segment AB, where A has coordinates x1 and y1, and point B has coordinates x2 and y2, the coordinates of the midpoint of that segment AB are specified by this formula right here. In addition to that, you've got a visual on what the midpoint formula does. I like this visual. So here's our segment A and B. And if we're looking for the middle of it, what we do is, get my highlighter out, focus on this segment right here. It's got endpoints of x1 and x2. So to find the middle of that, it's like finding their average. Add 2 things up, divide by 2, you'll get the middle of them. It's for the arithmetic average. Then focus on the vertical segment right here, which has endpoints y1 and y2. So to find the middle of those, you would add them up and divide by 2. And that leads us to our the coordinates of our midpoint there. Okay, now this example is similar. We're going to use the same formula, but it's a little different in that we're being asked to find an endpoint this time. So we are given the midpoint of segment CD being -2, 1, and we're given one of the endpoints, C, which is at -5, 7, and then we're being asked to find the coordinates of the other endpoint, point D. I want to put this on the graph first so we have an idea of what's going on. C is at -5, 7. The midpoint is given to us to be -2, 1, and then we're asked to find, I think D would be right about here. We're asked to find the coordinates of D. Okay, I'm going to label some x and y's on here now. We're going to let the midpoint be the regular x, regular y. Okay, we're going to let C represent the x sub 1 and the y sub 1 in the formula. And we're going to let our unknown point D be x sub 2, y sub 2. All right, so there's the visual. Let me show you that written down. We're going to have our, I like the highlighter, that was nice. The midpoint, negative 2, 1, be our x, y. We're going to have C be our x sub 1, y sub 1. And then that means we need to find D, our x sub 2, y sub 2. So when we substitute all those values into the midpoint formula, we have, let me go back to my pen. This is the regular x, so that's why you see the x right there. It's equal to, here is our x sub 1, that's why you see the negative 5 there. Our x sub 2 is the unknown, that's why you see that there. And then you divide by 2. Let me erase all my scratch work so that doesn't. Let me try it one more time with arrows. You take the x coordinate of the midpoint, and that goes first, so that's what it's equal to. Then you take the x coordinate of point C, so the endpoint you do know goes there. Then the x coordinate of that unknown midpoint goes right there. So it's all the x coordinate stuff first. The equal sign, the plus sign, and the divided by 2 is all constant stuff. That'll be there no matter what. Okay, so now if we take this equation and we solve for x sub 2, we'll have the first coordinate of our other endpoint, D. Okay, so to solve that for x sub 2, we would multiply both sides by 2, then add 5 to both sides, and we get x sub 2 is equivalent to positive 1. Positive 1. Oh, it even looks like it's at positive 1, the x coordinate of this midpoint of this endpoint here. Nice. Okay, we're going to do the same thing, except this time we're going to use all of the y coordinates. Let me switch colors. You're going to see the positive 1 first, then the equal sign, then the 7, then the plus sign, then the y sub 2, then the divided by 2. It looks like this. There's our 1, it's the y coordinate of the midpoint. Our 7, it is the y coordinate of the known endpoint. And y sub 2, it's the y coordinate of our unknown endpoint. So this formula right here, or equation rather, sorry, is all the y coordinates. So to solve for y sub 2, you start by multiplying both sides of the equal sign by 2, and then subtracting 7 from both sides. And we get y sub 2 is at negative 5, which I could see that. Yeah, if we're on the y-axis here, it looks like we're at negative 1, negative 2, negative 3, negative 4, negative 5. You can see that being at positive 1, negative 5, even with our super rough sketch there. No straight edge or anything. All right, and so the coordinates of that other endpoint D are positive 1, negative 5. Okay, so we just used the midpoint formula in two different ways. One where we had to find the midpoint and one where we had to find a missing endpoint. So make sure you practice with both of those. All right, we're moving to the distance formula now. And this formula is actually derived from the formula of a circle. It's related to the radius of the circle. So it's going to be the distance between 2 points. Our points are going to be A, which is at x sub 1, y sub 1, and B at x sub 2, y sub 2. And to find the distance formula, or to find basically the distance between those 2 points, we denote it with a lowercase d most often. And it's going to be the square root of, now we got a lot of work to do here. We have to do the difference of the x's squared plus sign, the difference of the y's squared. Okay? There's something that I learned to help remember this formula, and let's see if I can remember. It's been a long time now. The sum of the differences that's minus sign squared. That's the 2's. Okay, So I learned this a long time ago. It's helped me remember it. The sum of the differences squared. Try to say that with me. The sum of the differences squared. One last time, because this could really help you. The sum of the differences squared. And let me show you how that helps. The sum always reminded me to put a huge plus sign in the very middle of the differences. So that reminded me that these two are supposed to be minus signs. And then the last word, squared, reminds me to put these two squares on. I'm going to erase that that scratch work. And I'm going to show you how that works one more time. So whenever I am applying the distance formula, I like to go distance equals and the huge square root, and then I say that little rhyme to myself. The sum of the differences squared. And so what I've done now is created what I call a blank template. I love using blank templates. It gives me direction when working through my problems. I now know that I just have 1, 2, 3, 4 blanks to fill in, and then I can start my arithmetic. Okay, so let's try this example. Find the distance between point A, which is at positive 2, negative 5, and point B, which is at positive 1, negative 4. And they want us to give an exact distance and a 1 decimal place approximation. All right, so here we go. I start out with capital D equals the large square root sign, and then I say the sum of the differences squared. Now I can go plug in my 4 blanks. The x's go first, 2 and 1. And you have to go make sure whatever order you decided to put the x's in, you stay consistent. So I did the A first and then the B, so I have to do the same. I'll do the A first, which is negative 5, and then the B, which is negative 4. All right, now that I'm all set up, I know my signs are right. I know I didn't forget about those squares. Now I can start my arithmetic. Erase that. There it is, nicer for you. Okay, PEMDAS says do what's inside the parentheses first. So 1 minus 2 is negative 1, and negative 4 minus a negative 5 is positive 1. PEMDAS then says do the exponents. So negative 1 squared is 1, and positive 1 squared is 1. Now we're going to do the addition. That's the square root of 2. Now this right here, the square root of 2, that is the exact answer that they requested from us. And then the square root of 2, if you type it in your calculator, the square root sign for my calculator, I use a TI-84, which if you're going to continue with your math education, you might want to invest in one. I don't know, there's also a free app on your graphing calculator and lots of other tools, so it's up to you. But my square root symbol is in the first column, so I hit second square root, and I hit 2, and then enter. And the square root of 2 is an irrational number. It runs off my screen. It's like pi. It never repeats and it never terminates. But they asked us for it approximate to 1 decimal place. So that would, rounding to 1 decimal place would be approximately 1.4. And this is all linear units, the distance between 2 points, linear units. Okay. That will conclude our discussion on Chapter 1 and Section 1.7. My name is Jami Emigh. Thank you for joining me, and I will see you next time for our discussion on Chapter 2.